evening, Lava.
I'm Kyu Kyu Swe.
I'm Myat Thu Kha.
We are
From Group 16.
Now we are going to present about
Characteristics and applications of LVDT sensors. Before we explain about characteristics and applications of LVDT sensors, we have to know what LVDT sensor is. So, can you explain what LVDT sensor is?
Okay. LVDT sensor is an antonym of linear variable differential transformer, and it is a passive sensor. It takes linear displacements as an input stimuli and produces voltage as an output electrical signal. LVDT sensor can sense a wide variety of measurement ranges, typically from plus or minus 100 micrometer to plus or minus 25 centimeter. Excitation voltages range from 1 volt to 24 volt RMS, with frequency from 50 Hz to 20 kHz. LVDT are robust and absolute linear displacement transducer, and it has low hysteresis and excellent repeatability. So, Myat Thu Kha, what kinds of components are used to make LVDT sensors?
The components in LVDTs are primary coin, two secondary coin, and ferromagnetic core, shaft, shield, and handle. This is the structures of LVDT sensor.
And can you also explain about the constructions of the LVDT sensor?
Okay, I can.
The primary coin is joined with the AC voltage source, and the two secondary coins are connected in series opposite in LVDT sensors. The primary coin is in the center, and the two secondary coins are at the left and the right. The two secondary coins have equal numbers of turns. The ferromagnetic core is movable. Because of the movements of this core, the sensors can operate the output voltage. The output values of voltage depends on the displacements of the ferromagnetic core. This is the structures of LVDT sensors. It shows how the coins are placed in LVDT sensors.
Can you explain how the resultant voltage produced?
Okay, sure. The output voltage of the sensor is the differential output voltage between the two secondary coins. When the core is placed in the center, the differential output voltage will be 0. The displacements of the core fall equally from these two secondary coins. Thus, the output voltage of these two secondary coins are equal. This is the formula of output voltages. V output equals to V1 minus V2. When the core is nearer to secondary coin S1, the output voltage from this coin is greater than that of other secondary coin S2. The differential output voltage will have same value. The value of the output voltage of the coin that is nearer to the core is more than that of the other coin. When the differential output voltage is 0, the position of the core at the time is called null point.
Now, let's see how the output voltage will produce. The output voltage will be shown in this picture as an amplitude. When the core is nearer to S1, the amplitude of S1 is high. At the time, the amplitude of S2 is low. There is some values of amplitudes in differential output voltage. When the core is nearer to S2, the amplitude of S2 is high, and that of S1 is low. Then, the amplitude of differential output voltage has some change. The amplitude of differential output voltage is 0 when the amplitudes of S1 and S2 are equal.
There are two kinds of output voltage form. One is AC voltage form and the other one is DC voltage form. LVDT sensor produces output voltage in the forms of AC voltage. But DC voltage form can be converted from AC voltage form by using suitable electronic circuit. The output voltage in AC form are as shown in figures. The magnitude of output voltage varies with the core position. It changes in linear till the maximum core position point. The magnitude of output voltage depends upon the amplitude of the primary excitation voltage and the sensitivity factors of that LVDT at maximum core displacement from null position. And null does not occur in practical when the core is placed in the center. There are mismatch between the two secondary windings and leakage inductance. As simple measurements of the output voltage will not tell the size of the null position on which the core resides. The signal conditioning circuit removes these difficulties.
This is the characteristics of DC output voltage.
Okay, now we have discussed about characteristics of LVDT sensor. So let's move on to the applications of LVDT sensor. LVDT sensors are used to measure not only linear displacements but also pressure, load, acceleration, force, and weight.
LVDT sensors are used in industrial, military, aerospace, subsea, downhole drilling, nuclear power, and process control applications.
Depending upon the temperature, salinity, oxygen levels, and seawater depths, the LVDT is often the only technology that can deliver accurate and reliable performance in subsea conditions. LVDT linear position sensors are widely used for condition monitoring system as a part of control and safety functions for applications in offshore platforms, desalination systems, mooring cables, seafloor wellheads, and oil and gas gathering systems.
LVDTs are used extensively to provide displacement feedback for hydraulic cylinders. Several mounting configurations, both internal and external, are discussed.
To summarize our presentation, LVDT sensor is linear variable differential transformer, and the sensor is passive sensor, and it is also absolute sensor. It takes linear displacement as an input stimuli, and it produces voltage as an output electrical signal. There are two types of output voltage. The first one is AC voltage form, and then others is DC voltage form. And generally, the LVDT sensor produce the output voltage as output voltage in the forms of AC voltage. But if we want to get DC voltage form, we need the help of electric circuit.
To summarize applications of LVDT sensor had been used since Second World War in military. Nowadays, LVDT sensors are widely used as commercial products because of their low hysteresis and excellent repeatability, and also they are robust. We have described two types of applications of LVDT sensor in the previous slide, like subsea applications and hydraulics application. Actually, there are many other applications that can be measured by using LVDT sensors.
After learning this LVDT sensor, we have more knowledge about these sensors, and we also knew the other sensor like RVDT, yeah. And during the preparations of this presentation assignment, we have to find the information from Google, and we have known so many things, and we have some difficulties in preparation, and like my like is her dislike, and her like is my dislike. So we have to adjust these little things. These mismatches
left adds unforgettable memories for us, and the friendships between us is become stronger and stronger, I think. And
so thank you so much for your attention. ကျေးဇူးတင်ပါတယ်. Bye bye.